everybody. So what I'm going to show you in these next couple consecutive videos here is I'm going to show you 3 different ways that you can solve for the limiting reagent. So in the previous video, we talked about what actually is the limiting reagent. And we said that it was the reactant that is going to limit the amount of product we can actually make. And we used an example of a Big Mac where the pickles limited how many successful, complete, full Big Macs we could actually make. So we're going to look at an example here. We're going to look at this particular example here where it says 47.3 grams of nickel nitrate is mixed with 103 grams of potassium chloride to produce nickel chloride and potassium nitrate. Which one is the limiting reactant? Again, I said this could be limiting reactant. This could also be limiting reagent. Either of those terms are the same. They go back and forth. You can use either one. It doesn't really impact what you're actually saying. So as with every question ever in chemistry is what it feels like, we're going to start with the balanced chemical equation. So I know that I have nickel and nitrate. Nickel and nitrate reacting. I know that nickel has a +2 charge, nitrate has a -1 charge, which is why I've written it as such, is being mixed with potassium chloride. Potassium has a +1 charge, chloride has a -1 charge. And this question was really nice. They actually told us what our products are going to be. We were told that it's nickel chloride, and we were told that it's potassium nitrate, KNO3. So the first step that we need to do here is we need to balance this chemical equation. I would see 2 unique features right away. I'd see this 2 over on the left with the NO3. I would try putting a 2 out in front of the KNO3. So now I have 2 potassiums and 2 of this entire nitrate group. I've unbalanced my potassiums. I've created another issue for myself, so I need to resolve that issue. And I need to put a 2 in front of the KCl. And then the other one that I could have started with was the chlorine here. Now I have 2 chlorines on both sides, so that becomes balanced. So in this first way, what we're going to do is we're going to convert both reactants to moles. That's the first thing that we're going to do. We're going to convert both reactants to moles. And I've broken this down into 4 steps here so that we can follow those steps. In the preceding 2 questions, it's also 4 steps, but they're a little bit varied in the steps that you use. You always start with the balanced chemical equation, but from steps 2 to 4, that'll slightly change depending on the method you use. So we want to convert the given information into moles. So the first thing that I want to do is I have 2 different compounds that I need to start off with. I have 47.3 grams of Ni, bracket NO3, 2. And what I'll need to do then is I will need to figure out what the molar mass of that is. So I'll bring my calculator down here and I'll jump over to my periodic table. So nickel has a mass of 58.69, and then what we saw that we had 2 nitrogens. So in our reaction here, this little 2 applies to the nitrogens. It also applies to the oxygens, so it would be 2 nitrogens and 2 times 3, 6 oxygens. So what I'm actually going to do here is I'm going to, just because this calculator works the way it does, I'm going to do 6 times 16 so that I don't have to enter that later. I'm going to enter 14.01, 14.01, so that's like adding it in twice. And then I'm going to add in the nickel, 58.69, and we get a molar mass of 182.71. So time sign line. We have 182.71 grams, and that will convert into 1 mole of NiNO3, little 2 beside it. So we have 47.3 divided by 182.71, and that's going to be equal to 0.259 moles. 0.259 moles of NiNO3, 2. Okay, and then the other thing that we need to do, so that was for just one of our reactants. The other thing we need to do is look at our 103 grams of potassium chloride of KCl. Again, I'm going to do time sign line, and eventually I want to convert this into moles of KCl. So potassium Potassium has a mass of 39.10, so 39.10. And chlorine, which is over on the right, over here in column 17, we have a 35.45 mass. So the total atomic mass would be 74.55. 74.55 grams. Okay, and now what we need to do is we need to take our 103 grams, divide that by 74.55, and we will find out that you have 1.38 moles. Find out that you have 1.38 moles of KCl. Okay, so now we're in moles, and it would be tempting to just conclude the question there. However, what we looked at with the Big Mac was we said it's not just that you need 1 mole of patties, you actually need 3 moles of patties because there are 3 patties on a Big Mac. Likewise, you don't just need 1 mole of KCl, you need 2 moles of KCl for this reaction to go to completion. We only need 1 mole of NiNO3 too. So divide your mole values by the coefficients in the balanced chemical equation. Again, those coefficients are the numbers that go out front. So for the 0.259 moles of NiNO3 we would divide that by 1 because that was our balancing coefficient number, and I can tell you that any number divided by 1 is the same number itself, 0.259 moles of NiNO3. Okay, then what we need to do is we need to take our 1.38 moles of KCl, and we need to divide that by the balancing coefficient. Well, the balancing coefficient for KCl was 2 in this case, so we need to divide 1.38 divided by 2. And when we do that, we get an answer of 0.69 moles of KCl. Now what you want to do is you want to directly compare these two molar values. You want to compare those two molar values, and whatever number is smaller will be the limiting reactant. I'm putting LR beside, I'm going to call it limiting reagent. I'm putting LR because that's usually how I would identify which of these two compounds was the limiting reagent. Now the next step, if we were to do that, would be to say, okay, let's take whatever the limiting reagent is. We need to start with the limiting reagent because that's what's actually limiting the amount of product that we can produce. And then we need to go into grams or moles of whatever the question asks of us. So that's method 1 of how to find out what the limiting reagent is.